Hey 5th grade, Miss Kachibata here. This is the video for week 6, day 2, and this is directly aligned with the Eureka Math Module 5, lesson 13. So our objective today is I can multiply mixed number factors and relate to the distributive property and area model. So we've been multiplying mixed numbers, and we've been using the area model to do it. So today I'm going to teach you the distributive property way to do it. And we'll go from there. So for the daily fluency, we are going to multiply fractions and simplify where necessary. Okay, so go ahead and if you're still struggling with this, you can work through it with me, or you can pause the video here and complete the problems and then go over them with me, which I would really like for you to do that. And I know that the majority of you are able to. So remember, when we multiply fractions, we just multiply straight across, especially when they're easy, friendly numbers like these. So 1 times 1 is 1, and 2 times 5 is 10. I know that I can't simplify 1/10 because there's nothing that divides into both 1 and 10. So 1/10 is my final answer here. All right, moving over to the right, 1 times 3 is going to give me 3, and 5 times 4 is 20. Again, this is in its simplest form, so my final answer is 320. On the bottom left, we have 3 times 7, which is 21, and 4 times 8, which is going to give us 32. And that's going to be my final answer there. All right, and then I have 3 times 3, which is 9. And 4 times 4, which is 16. And that is also going to be my final answer. Sorry, I was also thinking to make sure that nothing divided into both. So you should have 9/16. Okay, moving on down, we're going to find the volume. Okay, it says remember to include the units, so we'll use cubic centimeters. Anytime it doesn't give you the units, just use cubic centimeters, and that's fine, because these are cute little centimeter cubes that they have right there. So remember, volume is length times width times height. Okay, so length, how long it is, we have 1, 2, 3, 4, 5 centimeters. The width, how wide it is, we have 3 centimeters. And how tall it is, the height is 2 centimeters. Okay, if I plug that into the volume formula, V equals 5 centimeters, I'm including those units, times 3 centimeters times 2 centimeters. Okay, go ahead and solve. I'm going to multiply 5 centimeters times 3 centimeters first, and that's going to give me 15 square centimeters times 2 centimeters. Okay, and then 15 times 2 is going to give me 30 cubic centimeters. So that's what you should have for the volume for the first one. All right, feel free to pause here so you can try to do the next one on your own if you haven't already. I really want to encourage you to still push yourself during this time, even though I'm not there to, have you do it first and then we go over it, but still try to do it on your own first before checking the answer. Okay, so again, the length here is 1, 2, 3, 4, 5, 6 centimeters. Okay. The width is going to be right here, 1, 2 centimeters. And the height is going to be 1, 2, 3, 4 centimeters. Okay. Again, plugging that into the volume formula, V equals 6 centimeters times 2 centimeters times 4 centimeters. Okay, 6 centimeters times 2 centimeters is going to be 12 square centimeters. And then times 4 centimeters. So if I multiply 12 times 4, that's going to give me 48 cubic centimeters for the volume. All right, go ahead and go to the next page. Okay, so if you look at this and are like, oh my gosh, why is there so much writing on here? I totally understand. It's really not anything that you don't already know how to do or anything we haven't done. It's just that it's a lot on one page. So up at the top, all they did right here on A is they had one of the dimensions was a fraction greater than 1, 35/4. So they just went ahead and converted 2 3/7 into a fraction greater than 1. And then they just multiplied using the simplifying strategy. So that's really all they did there. And then for their final answer, they put it back into a mixed number. And then at the bottom, they used, this is an example of the area model, and then they've just written out, and then they added all their partial products at the bottom like we've done. And so again, this isn't anything that you haven't seen before, it's just that it's a lot. So we're going to skip over this page. Okay, here is one example of what we're going to do. So here they use the area model like we've been doing, and then over here, this is where they solved this using the distributive property. Okay, and that's what I'm going to go over now. So, and I'm going to use this example to help me, so I'm going to scroll down so that I have more room. And they wrote 4 3/4 times 2.5. Okay. So 4 3/4 times 2 1/2. So I'm not going to work the whole thing out. I'm just going to show you how it connects step by step on a blank page at the bottom so that it's a little easier to see than the top, what they have at the top. So all that the distributive property is it really is the same things that you're multiplying together when you use the area model, and it's that process of taking a big multiplication problem and breaking it down into smaller multiplication problems to then add all together. So it's the same exact thing that you're doing on the area model without the area model, basically. So the first thing you're going to do is you're going to take this multiplication sentence and you're going to rewrite it, breaking up the whole numbers and the fractions, just like you would do if you were labeling your area model. So I'm going to write 4 plus 3/4 in parentheses times 2 plus 1/2. All right, so I'm going to write it that way. And now I'm going to show you how to make 4 smaller multiplication problems the same way that you do it on the area model. And then I'm going to scroll up so you can see how it's related. So the first thing I'm going to do is I'm going to start at the 4 here. And I actually do draw these lines when I do the distributive property because that's how my teacher taught it to me when I was a kid. And it really is helpful to see. So I make sure I multiply all of the numbers. So you're going to start with the 4. And I'm going to first multiply 4 times 2. Always that first number to the first number. So I'm going to come down here. And in parentheses, I'm going to write 4 times 2. And now I'm going to put a plus sign because remember, these are like when we do all the little multiplication problems in the area model and then we add them all up, we add up the partial products. That's exactly what we're doing here. All right, we're just writing it out. So now I'm going to say, okay, I'm going back to the 4. Now I need to say 4 times 1/2. All right, so again, I'm going to write parentheses and I'm going to write 4 times 1/2. Close parentheses, plus sign. Okay, now I'm going to say 3/4, right? I'm going to start there this time. I'm going to use a different color so you can see. I'm going to say 3/4 times 2. Okay, again, I'm just multiplying the 3/4 by both of the numbers in the other problem. Okay, so now I'm going to write 3/4 times 2 and a plus sign. And then once again, I'm going to start at 3/4 and I'm going to multiply it by the last number that I have. 3/4 times 1/2. Okay, now, if I scroll up to the area model, everything I wrote here is going to be on there too. So 4 times 2, if I look up here, this is where I multiplied 4 times 2, right? The 4 here times the 2 right here, okay? If I scroll back down, the next one I had was 4 times 1/2, all right? That's right here where I multiplied this 4 times this 1/2, okay? Then I had 3/4 times 2, okay? That's right here, 3/4 times 2, okay? And then 3/4 times 1/2, and that's right here, 3/4 times 1/2. So again, it's the same thing. It's the same thing as the area model. We're just writing it out. And then you would go on to solve. So again, it's just like finding the partial products in the area model. 4 times 2 is going to give us 8. And you can do these in parentheses or not. This part you don't have to have in parentheses. 8, okay, plus 4 times 1/2 I know is going to give me 4 times 1/2. And that's going to give me 4/2, which I know is the same as 2. Okay. I have 3/4 times 2. So that's going to give me 3 times 2/4, which is going to give me 6/4. And you can either leave it like that, or you can go ahead and put it into a mixed number. All right, your choice, whatever you think is easier. If you put it into a mixed number, then it's 1 2/4, which we know is the same as 1 1/2. So 1 1/2 plus 3/4 times 1/2. So that's going to give me 3/8. All right, and now you add it all up together, and that's exactly what you would have done up here, right here. See, they kept it as 4/2, but then down here they changed it. But that's still where you added up everything that you got, all of these 4 partial products right here. And then you would just go down until you got your answer, which was 11 7/8. Okay? So that is the distributive property. So, again, it does take some practice. So if you need to watch that again for it to make sense, rewind, watch it again, and then we're going to move on. Okay. So we're finding the area of the rectangles, and it says draw a model if it helps you. So again, if distributive property is not making any sense to you whatsoever and you've tried to understand it, just use the area model, okay? It is completely fine if that's how you want to use it for now, all right? Or if that's how you want to solve these problems. So they already solved A for us here, 3 square kilometers, all right? If you want to, you can, if you really wanted to, you can also work that one out, but you know, they've already done it, so you don't have to. So they've done part of B on the area model, and we just have to fill it in, okay? So here they multiplied 16 times 4, and they got 64. Then they multiplied 4 times 1/2, and they simplified and got 2 square meters, okay? Now here we need to multiply 16 times 1/5. So let me scroll down so I have some room. So I have 16 times 1/5. I'm going to rewrite that as 16 times 1/5, which is going to give me 16/5. You can keep it that way, or you can rename it as a mixed number. How many times does 5 go into 16? I know that 5 goes into 16 3 times. 5 times 3 is 15, so I have 1 more to get to 16, and my denominator is 5. So 3 1/5. Okay, so I'm going to add that down here, 3 1/5. All right, and then I need to multiply my last one, 1/2 times 1/5, and that's going to give me 1/10. Okay. And I'm going to write that down here too. 1/10. All right, they did not give us the answers, so we need to add them all together. I'm going to erase my work down here. Okay. So I'm going to add 64 plus 2 plus 3 1/5 plus 1/10. Okay. I know that I can go ahead and add like units, so I'm going to add 64 plus 2, and that's going to give me 66. All right, I'm going to go ahead and add 66 plus the 3, 69, and that's going to give me 69. So now I have 69 1/5 plus 1/10. All right. I'm going to go ahead and find my common denominator because, again, I know that I can't add two fractions when they have different denominators. So I'm going to say, okay, what is the smallest number that 5 and 10 have in common? If I skip count by 5 and 10, what's the first number they have in common? All right, and that's going to be 10. So if you need that visual, 5, 10, 15, 20, and then 10, 20, 30, 40, all right? There are other numbers they have in common, but the first number they have in common is 10. So that's going to give me my LCM. So I'm going to create two new fractions with 10 as the denominator, and I'm not going to forget to put my 69 down there. So now I'm going to use multiplication to find the equivalent fractions. I'm going to say 5 times what gives me 10? 5 times 2 gives me 10. And 1 times 2 is 2. So my new fraction is 69 2/10. Then I don't have to do anything here because, again, 1/10 already has 10 as the denominator. So I'm just going to put a 1 as my numerator for my equivalent fraction because it's going to stay the same. All right. So now if I add this up, that's going to give me 69 3/10 square meters. Okay. So up here, I'm going to go back and write 69 3/10. Okay. Now, I could have also solved this using the distributive property. I'm not going to go through the whole thing and solve, but I will show you how to write it as the distributive property just to give you that extra practice again. All right, so the problem was 16 1/2 times 4 1/5. What did I just do? 16 1/2. Times 4 1/5. All right, so I'm just going to show you again the process of writing this using the distributive property. So I'm going to first break these apart into expanded form. So I'm going to rewrite this as 16 plus 1/2 in parentheses. And then I'm going to write 4 plus 1/5. Okay, and now I'm ready to use the distributive property to create 4 smaller multiplication sentences or multiplication problems. Okay, so first I'm going to start with my first number, 16, and I'm going to first multiply 16 by 4. So I'm going to come down here and I'm going to write 16 times 4, okay, plus. I'm going to go back up to the 16, and I'm going to now multiply 16 times 1/5. Okay, plus, same thing here. Now I'm going to start with the 1/2, and I'm going to say 1/2 times 4. Plus, and then I'm going to go back to the 1/2 and say 1/2 times 1/5. And there you go. You have your 4 multiplication problems that you solved up in your area model up top. Okay? So again, I just want to go over the process of using the distributive property one more time, and then you would multiply these together just like we did. Multiply each of these, I'm sorry, and then add the partial products together just like we did above. Okay, so when you're ready, go ahead and flip to the next page. Okay, this is our final problem, and it is a very, very tricky one, just so you're ready, all right? I'm probably going to have to use more paper, or I'm probably going to have to erase some of my work and go back because I don't think I'm going to have enough room on here. So let me see, maybe I can do this and use some space over here. Oh yes, I can use that as a whiteboard. Okay, so it says the community pool is connected to a pool house by a sidewalk as shown. The community wants to buy grass for the lawn, shown in gray. How much grass do they need to buy? Okay, so this is a tricky problem because you're looking at it, so you're probably thinking, oh, well, I just need to multiply 24 1/2 times 24 1/2 and be done. But remember, the pool house here and the pool and this sidewalk, this is all building, right? So you can't put grass, over a building. So we don't need grass for that area. All right, so what we have to think first is, okay, here's what I need to know, right? What are some things I need to know? I need to know the area of the lawn, right? So I need to know the area of the lawn. I don't know what that is yet. Okay. I need to know the area of the pool house. I do know what that is because they gave it to me. It's 16 square yards. Okay. I need to know the area of the sidewalk. And they also gave that to me, which is 3 yards. Because it's 3 yards long. And then I need to know the area of the pool, which they didn't give me, but they did give me the dimensions to figure it out. Okay. So I am going to, oops, I forgot my squared there. All right, so first I'm going to figure out the area of the lawn. All right, I'll start there. You can start wherever you want. If you started with the pool first, that's totally fine. I'm going to start with the lawn. So I'm going to label my work so I know. Well, that's what I'm doing. And I'm going to say, okay, this is the lawn here. Okay. So the lawn is 24 1/2 yards times 24 1/2. All right. So I'm going to use the distributive property here. If you want to draw an area model, that's fine. But I'm going to use the distributive property. So the first thing I'm going to do is I'm going to break these up in expanded form. So I'm going to have 24 plus 1/2. And then I'm going to have times, 24 plus 1/2. Okay. And now I'm going to use the distributive property. So I'm going to start with 24. And I'm going to say 24 times 24. Write that down. Okay. Plus, then I'm going to go back and I'm going to say, okay, 24 times 1/2. Okay. Then I am going to start with the 1/2, and I'm going to say 1/2 times 24. Plus, I'm going to go back to that 1/2, whoops, and I'm going to say 1/2 times 1/2. Okay. Now I have 4 smaller multiplication problems to solve. All right, so I have 24 times 24, all right? I do not know what that is off the top of my head. So I'm going to come over to my scratch paper and I'm going to say, all right, 24 times 24. 4 times 4 is 16. 4 times 2 is 8, plus 1 more is 9. I'm done with this one. All right, I'm going to start multiplying in the tens place, which means I have to start recording in the tens place. So I'm going to put a 0 in the ones place. Then I'm going to start multiplying. 2 times 4 is 8. And 2 times 2 is 4. I add those up. 6 plus 0 is 6. 9 plus 8 is 17. And 4 plus 1 is 5. Okay, so we're going to come back over here, and now I know that 24 times 24 is going to give me 576 plus 24 times 1/2. All right, so 24 times 1 over 2 is going to give me 24 halves. And I know that 2 goes into 24 12 times. So this is equal to 12. All right, come over here and write 12 there. All right, next I have 1/2 plus 24. Again, I know that that's the same exact thing, so it's going to give me the same answer, which is going to be 12. And then I have 1/2 times 1/2, which is 1/4. Okay. Get rid of this. All right, if I add all these up, 576 plus 12 plus 12. 6, 7, 8, 9, 10. Okay, 7, 8, 9, 10. And 5 plus 1 is 6. That's going to give me 600 and you're not going to be able to see that, and 1/4. Okay, so I'm going to go back up, and now I know that the lawn has an area of 600 and 1/4 square yards. Okay, now I know what the pool house area is. I know what the area of the sidewalk is. Now I need to figure out the area of the pool. Okay, so once again, we're going to have to do all of this. So let me see if I can, no, that did not work. Okay. All right, so now we have to find the area of the pool. So hopefully you have more room. I'm going to erase the work that I did for the lawn, okay, since I wrote what the area of the lawn is. So if you need that, go ahead and pause here so you can finish. Hopefully you should have already paused anyway, so you could continue and stay on pace with me. I'm going to erase my work that I did on for the lawn, and then I'll be able to do the pool. So... all right, there we go. So now I am going to find the area of the pool. Okay. So to do that, I can see that it gives me the side length. So I'm going to multiply 2 and 1/2. Wait, actually I'm going to start over here. 2 and 1/2 times 7 and 1/2. Okay. So once again, go ahead and start by breaking this up into expanded form, each of these. All right, so I'm going to write 2.5 as 2 plus 1/2 times, and then I'm going to break up 7.5, 7 plus 1/2. All right, starting with the 2, I'm going to multiply 2 times 7. Plus, then I'm going to multiply 2 times 1/2. Okay, then I'm going to start with the 1/2, and I'm going to say 1/2 times 7. my plus sign, and then finally I'm going to say 1/2 times 1/2. All right, so now I'm going to solve each one. So first I have 2 times 7, and we know what that is. So 2 times 7 is 14. Plus, all right, then I have 2 times 1/2. Okay, so if I say, let me erase my, oh, it won't let me erase that. That's weird. There we go. All right, if I say, let's see, 2 times 1/2, that is going to give me 2/2, which is the same as 1 whole. So now I have 1 whole here. Plus, all right, I have 1/2 times 7. So 1 times 7/2. All right, that's going to give me 7/2. You can choose to keep it that way, or you can put it into a mixed number. So 2 is going to go into 7. How many times? It's going to go into it 3 times. 2 times 3 is 6. So that means I have 1 more to get to 7, and my denominator is 2. So it gives me 3 1/2. And then 1/2 times 1/2 is 1/4. All right, so now I'm going to add all these together. 14 plus 1 is 15, and then 15 plus 3 is going to give me 18. So now I have 18 1/2 plus 1/4. All right, I need to come up with like units, but I also know that I have 18 1/2, and I know that 1/2, if I wanted to put 1/2 into fourths, I could rewrite it as 2/4. So if you didn't know that off the top of your head, then you can just come up with the common denominator, which is going to give you 4, and it's going to be the same thing. But I know that 1/2 is the same as 2/4. So I'm going to rewrite this as 18 2/4 plus 1/4 is going to give me 18 3/4 square yards as my area for the pool. Okay, so I'm going to go back up. I'm going to add that there. Okay. All right. So again, I'm about to erase this because we're still not done. So if you're like, oh yeah, I'm finally done with the problem, remember we have to still figure out how much grass they need to buy. So go ahead and pause this and finish copying this down, catch up if you are not there yet, because I am going to erase it now. Right. Okay. So we're going to scroll back up. Now that we've figured out what the area of everything is, all right, the area of the entire lawn is 600 1/4 yards, right? Okay. Now, we need to know how much grass to put down, but we don't need to include any of this space, right? Because there's buildings and stuff there. So we don't need grass. So I'm going to think, okay, I know that the lawn is 600 1/4 yards, but I need to not include the part of the building, right? Of the buildings that are there in the sidewalk. So if I know the area of everything right now, I know the area of the lawn, I know the area of the pool house, the sidewalk, and the pool. I'm going to start with the area of the lawn, and I'm going to subtract the area of the pool house, the sidewalk, and the pool, because I don't need to include that in my order for grass. So I'm going to say 600 1/4 minus, I'm going to start with the pool house, 16 yards, minus the sidewalk, which is 3 yards, minus the pool, which is 18 3/4 of a yard. Squared. All of these are squared. Okay. Okay, so now I'm going to start with my whole numbers. So I know that I'm going to start with 600. All right, I'm going to say 600 minus 16. All right, So I know I can't take 6 from 0. I can't take 1 from 0, so I got to borrow from this 6, and it's going to become a 5. I'm going to regroup into that tens place and make this a 10. All right, but now I need to borrow 1 from the 10 so I can regroup. So I'm going to make this 10 a 9 and regroup into the ones place so I can make that 0 a 10. All right, 10 minus 6 is 4, 9 minus 1 is 8, and 5 minus 0 is 5. So now I have 584. Now, so the 16 is done. We're done with the 16 yards. So this is going to give us 584 and 1/4 yard, square yards, minus 3 yards, 3 square yards, minus 18 and 3/4 square yards. Okay, so now I'm going to take the 584 and I'm going to subtract 3. All right, and when I do that, I'm going to get 581. All right, and now I'm going to need to subtract the 18. So I have 584 minus 3 gives us 581. And now I need to subtract 581 minus 18. All right, ask yourself, can I take 8 from 1? No, so I'm going to go to that tens place, borrow from this 8 and make it a 7, and then regroup into the ones place and make this an 11. All right, 11 minus 8 is going to give me 3, 7 minus 1 is 6, and 5 minus 0 is 5. All right, so that gives us 563 and 1/4 minus 3/4. Now, there's a couple ways you could do this. All right, you could take 1 from the 563 and you could add 4/4 to that 1/4, right? Because 4/4 is equal to 1 whole. You could also, and then, so you would make that 5/4. You could also just think, okay, let me think of a number line. If I have a number line here, and this is 562, this is 563, and this is 564. All right, and I have these divided into fourths, so 562 and, let me use a different color, and 1/4, 2/4, 3/4, and then 4/4 is 563. 563 and 1/4, 2/4, 3/4, and then 564. So I'm going to start at 563 and 1/4 right here. And I'm going to jump back 3/4. 1, 2, 3. Well, this is 562. This is 562 and 1/4. And this is 562 and 2/4. So that gives me 562 and 2/4, which I know is the same as 562 and 1/2 square yards. So the original question that we are answering, how much grass do they need to buy? This is the word problem, so we're going to write a statement. They need to buy 562 and 1/2 square yards of grass. All right, you did it. Congratulations. All right, if you stuck it through and you did all that work, you probably had to use the back of your paper or something, because I cannot imagine that you could fit all of that on your paper, but awesome job. All right, please reach out if you have any questions. Go to Microsoft Teams for the anchor charts. I also posted them on my Instagram story yesterday. Any of the anchor charts that you're going to need for this week. Tomorrow starts the lessons on shapes, quadrilaterals, which we also had already done, or we were finishing anyway when school closed. So look for that video tomorrow, and reach out if you have any questions. All right, I will talk to you guys soon. Bye.